High above the waters of the Persian Gulf, one of the most advanced surveillance aircraft in the world was on mission. The aircraft was not a fighter jet, not a bomber, not even a piloted plane. It was an unmanned intelligence platform, the MQ-4C Triton. Designed to fly at over 50,000 feet, capable of scanning vast ocean territories, the Triton is part of a new era of military strategy, persistent surveillance without risking pilots. Then came the report. According to media discussions, including commentary aired by Pakistan's 24 News HD, an American MQ-4C Triton reportedly transmitted an emergency signal and then disappeared from tracking systems over the Persian Gulf. No debris field. No confirmed crash site. No official explanation. Just silence. Within hours, speculation spread across defense forums and social media platforms. Was it a malfunction? A shutdown? A classified operation? Or something more serious, electronic warfare? But before jumping to conclusions, one question must be asked. What is confirmed and what is not? As of this moment, there has been no official public confirmation from the US Navy stating that a Triton was destroyed, captured, or electronically taken over. That distinction matters. Because in modern information warfare, narratives can spread faster than facts. The MQ-4C Triton is not an ordinary drone. It is a high-altitude, long-endurance maritime surveillance system developed for strategic intelligence missions. Based on the Global Hawk platform, it carries advanced radar systems capable of scanning enormous maritime areas in a single flight. Its purpose is clear. Monitor shipping lanes. Track military movement. Provide real-time intelligence. Support naval operations. Each aircraft costs over $100 million. More importantly, it represents a symbol of technological superiority, encrypted satellite links, autonomous navigation, anti-jam systems, and multi-layer communications. This is not consumer-grade equipment. This is strategic military infrastructure. If such a platform were disabled through electronic warfare, it would signal a dramatic shift in power dynamics. That is why the story gained attention. Not because a drone might be lost, but because of what that loss could mean. The most explosive claim circulating in commentary is that advanced electronic warfare, possibly linked to Chinese technology, may have played a role. The theory suggests that signal jamming or GPS spoofing disrupted the drone's communications. But here is the critical point. There is no verified official statement confirming this. China is a global leader in electronic warfare development. Iran has invested heavily in asymmetric warfare capabilities. Defense cooperation between nations is common in global geopolitics. However, linking a specific incident to Chinese systems requires evidence. And at this time, no independently verified defense source has provided such evidence. This is where responsible analysis becomes essential. There are several possible explanations for a military aircraft disappearing from public tracking. The transponder was intentionally disabled. The aircraft switched to secure classified communication channels. A technical malfunction occurred. Weather or signal interference disrupted civilian tracking data. Or, in more serious cases, hostile action occurred. Without official confirmation, every explanation remains hypothetical. Modern warfare is no longer defined only by missiles and bombs. It is increasingly defined by signals, by invisible battles in the electromagnetic spectrum. If an advanced surveillance drone truly vanished due to electronic interference, it would mark a new chapter in military history. But until facts are verified, the responsible approach is not accusation, it is investigation. In the next part, we examine the aircraft itself. What exactly is the MQ-4C Triton capable of? And how difficult would it really be to jam, disrupt, or hijack such a system? To understand whether an MQ-4C could be jammed, disrupted, or forced offline, we must first understand what it is. The aircraft at the center of this discussion is the Northrop Grumman MQ-4C Triton. Developed for the US Navy, the Triton is a high-altitude, long-endurance unmanned aerial vehicle designed specifically for maritime intelligence, surveillance, and reconnaissance, often referred to as ISR missions. It operates at altitudes exceeding 50,000 feet. It can remain airborne for more than 24 hours. It can monitor millions of square miles in a single deployment. Unlike smaller tactical drones, the Triton is a strategic asset. It is built to function as a persistent eye in the sky capable of scanning sea lanes, tracking vessels, detecting suspicious activity, and relaying real-time intelligence back to command centers thousands of kilometers away. Its radar system can detect and classify ships across vast distances. Its sensor suite is engineered to operate in harsh maritime environments, including storms and heavy cloud cover. In simple terms, this is not a fragile drone operating on Wi-Fi. It is a hardened military platform built for contested environments. And that brings us to the central question: how vulnerable is it? Modern unmanned aircraft rely on layered communication systems. The MQ-4C primarily uses satellite communication, SATCOM, links, encrypted data transmission channels, autonomous onboard navigation systems, backup flight control protocols. If the primary communication link is interrupted, the aircraft does not immediately fall from the sky. It is programmed with contingency logic, including return-to-base procedures. Military-grade drones do not rely on standard GPS alone. They integrate inertial navigation systems that allow them to continue flying even if satellite signals are degraded. For electronic warfare to cause a total loss of control, multiple layers would need to be compromised. 1. Disruption of satellite uplink. 2. Interference with encrypted control signals. 3. Navigation spoofing or corruption. 4. Failure of onboard autonomous recovery systems. That is not impossible. But it is complex. Electronic warfare at this level requires advanced capabilities, not just signal noise, but targeted, high-power, precision interference. Which leads to the broader battlefield, the electromagnetic spectrum. Modern conflicts are increasingly fought in frequencies, not just fields. Electronic warfare includes jamming overwhelming communication signals, spoofing, sending false navigation data, signal interception, capturing encrypted transmissions, cyber-electronic hybrid attacks. Countries around the world invest heavily in these capabilities because disabling an adversary's sensors can be as powerful as destroying their aircraft. In 2019, Iran shot down a U.S. surveillance drone, the Northrop Grumman MQ-4 Global Hawk, using a surface-to-air missile. That was a kinetic action, a physical strike. But electronic warfare is different. It leaves fewer visible traces. The question many analysts now ask is not whether jamming is possible, it is whether it is sufficient to override hardened military systems like those on board the MQ-4C. Because there is a difference between temporarily disrupting signals and permanently capturing or neutralizing a platform. Temporary jamming can interrupt communication. But a complete disappearance suggests either catastrophic failure, intentional shutdown, or physical destruction. Without official confirmation, we cannot assign a definitive cause. However, what we can say is this: the Triton was engineered with redundancy precisely because it is expected to operate near contested regions. Which makes the speculation even more significant. If such a platform were compromised electronically, it would signal a substantial evolution in electronic warfare capability. And that brings us to the geopolitical layer. Because technology does not exist in isolation. It exists within alliances, rivalries, and strategic partnerships. In Part 3, we examine Iran's electronic warfare development and analyze whether such a capability would align with its known military doctrine. To assess the plausibility of electronic interference, we must examine the strategic doctrine of Iran. Iran's military strategy has long emphasized asymmetry. Rather than matching major powers aircraft for aircraft or carrier for carrier, Iran has invested in tools that offset technological disadvantages. Ballistic missiles, fast attack naval craft, air defense systems, cyber capabilities, electronic warfare units. The logic is clear: if you cannot dominate the skies conventionally, you target the systems that make dominance possible: communications, sensors, navigation, coordination. Over the past decade, Iran has repeatedly claimed progress in electronic and cyber warfare domains. Some claims are verified. Others remain debated. But one incident stands out. In December 2011, Iran announced it had captured a U.S. stealth drone, the Lockheed Martin RQ-170 Sentinel. Iranian officials claimed they used electronic warfare techniques to interfere with the drone's navigation system and force it to land. The United States acknowledged losing the aircraft but did not confirm the exact cause. Analysts remain divided. Some argue that GPS spoofing could, in theory, mislead a drone if vulnerabilities exist. Others argue that sophisticated military UAVs integrate inertial navigation systems that make simple spoofing insufficient. What matters here is not whether the 2011 explanation was fully accurate. What matters is that Iran demonstrated 1. Interest in targeting unmanned systems. 2. Investment in electronic countermeasures. 3. A willingness to publicize such operations. This created a narrative: Iran as an emerging electronic warfare actor. Then, 8 years later, another major event occurred. In June 2019, Iran shot down a high-altitude American surveillance drone, the Northrop Grumman MQ-4 Global Hawk. Unlike the 2011 case, this incident was kinetic. A surface-to-air missile destroyed the aircraft. The United States confirmed the loss. Iran released video footage. The geopolitical tension escalated dramatically. This event demonstrated something crucial. Iran was willing to directly challenge advanced surveillance assets operating near its airspace. However, there is a key difference between missile engagement and electronic compromise. A missile strike leaves wreckage. Electronic warfare can leave ambiguity. If the MQ-4C Triton incident were electronic in nature, it would represent a more subtle, but potentially more strategic, shift. Electronic warfare offers plausible deniability. It complicates attribution. And it avoids immediate escalation. But the question remains. Does Iran possess the capability to penetrate or override the hardened systems of a modern Triton? Iran has developed indigenous radar systems and electronic countermeasure platforms. It has also reportedly acquired or studied foreign technologies over the years. However, there is no publicly verified evidence confirming that Iran has successfully electronically captured or disabled a next-generation MQ-4C. Which brings us to the controversial claim raised in some media discussions. Chinese technological involvement. In Part 4, we examine China's electronic warfare capabilities and assess whether such collaboration is technically plausible and strategically meaningful. When discussions turn to advanced signal jamming or satellite disruption, one country inevitably enters the conversation. China. Over the past 2 decades, China has heavily invested in electronic warfare, EW, cyber operations, and anti-satellite technologies. Modern military doctrine in Beijing emphasizes informationized warfare, controlling data, signals, and communications as a battlefield domain. China operates advanced ground-based jamming systems, space and satellite interference research programs, cyber-electronic hybrid capabilities, long-range radar and surveillance disruption platforms. From a purely technical perspective, China is one of the world's leading EW developers. But capability alone does not equal involvement. There is currently no verified public evidence that Chinese systems were used in any alleged disruption of an MQ-4C Triton. That distinction is critical. Speculation often fills the vacuum left by incomplete information. Strategically, Iran and China have maintained diplomatic and economic relations, including long-term cooperation agreements. Military technology exchanges between nations are not uncommon globally. However, open-source intelligence does not confirm that China has supplied Iran with the specific tools required to override or electronically capture hardened U.S. Navy UAV systems like the MQ-4C. To successfully disable such an aircraft electronically, a system would need to 1. Interfere with encrypted satellite communication links. 2. Overcome anti-jam frequency hopping protections. 3. Bypass onboard autonomous navigation safeguards. 4. Sustain high-power directional jamming at extreme altitude. This is not standard commercial signal disruption. It requires advanced, high-energy, precision equipment, and even then, results are uncertain. Military-grade UAVs are designed to expect interference. They are built to operate in contested electromagnetic environments. Which means even sophisticated electronic attack would likely cause disruption, not necessarily disappearance. So why does the Chinese technology narrative gain traction so quickly? Because it fits into a broader geopolitical framework. Rising U.S.China technological rivalry. Growing military tension in multiple regions. Concerns over electronic warfare supremacy. Increasing drone-based surveillance operations. In global politics, narratives often mirror larger strategic fears. If an advanced American drone vanished, it would symbolize vulnerability. If Chinese systems were involved, it would symbolize a shift in technological balance. But until verifiable data emerges, such connections remain theoretical. It is also important to remember. Military aircraft frequently disable public tracking transponders. Civilian tracking platforms do not reflect classified military networks. Emergency signals do not automatically imply hostile takeover. The absence of transparent information does not confirm electronic victory. It confirms operational secrecy. And that brings us to the final question. What would it mean if electronic warfare truly neutralized a high-altitude strategic drone? In Part 5, we step back and examine the future of drone warfare and whether the skies are becoming more vulnerable than ever before. If and this remains an if an advanced surveillance drone like the Northrop Grumman MQ-4C Triton, were successfully neutralized through electronic warfare, the implications would be profound. Modern militaries depend on persistent ISR, intelligence, surveillance, and reconnaissance. High-altitude UAVs provide maritime domain awareness, early warning intelligence, strategic deterrence, real-time targeting data. They reduce risk to pilots while expanding operational reach. If electronic systems can silently disable such assets, it changes the equation. Air superiority would no longer depend solely on aircraft and missiles. It would depend on spectrum dominance. The battlefield would shift further into invisible domains. Radio frequencies, satellite links, encryption layers, cyber-electronic integration. And nations would respond accordingly. Are high-altitude drones vulnerable? Yes, but not easily. Every advanced military system exists within a contest between defense and countermeasure. For every encryption upgrade, there is an attempt to penetrate it. For every anti-jam system, there is research into stronger interference. For every satellite network, there is exploration of disruption techniques. But vulnerability is not the same as fragility. The MQ-4C Triton was designed specifically for contested environments. It incorporates redundancy, secure communication protocols, and autonomous flight logic. To completely compromise such a system electronically would require exceptional technical sophistication, operational proximity or directional capability, multi-layer disruption coordination. It would not be accidental. It would be deliberate. And if it occurred, it would likely remain classified. Modern military incidents are often acknowledged only when strategically necessary. Silence can be policy. Perhaps the most revealing element of this story is not whether a drone vanished. It is how quickly narratives formed. Within hours of media commentary, discussions emerged linking Iran, Chinese technology, electronic superiority, and strategic escalation. This is the second battlefield of modern conflict. Information space. Speculation can influence public perception, shape geopolitical narratives, create deterrence effects, amplify strategic messaging. In many cases, ambiguity itself becomes a tool. If adversaries believe a capability exists, whether confirmed or not, it alters strategic calculations. That is why responsible analysis matters. At this time, there is no official confirmation that an MQ-4C Triton was electronically captured or disabled. There is no verified evidence that Chinese technology was used in such an event. There is no confirmed acknowledgement of hostile action. But the discussion itself reveals something important. The world is entering an era where drones patrol contested skies, satellites guide autonomous systems, electronic signals determine strategic advantage, and the most powerful weapons may be invisible. Whether this incident proves to be a malfunction, a procedural shutdown, a classified operation, or something more serious, it highlights a fundamental truth. Modern warfare is evolving. The skies are no longer controlled only by speed and firepower. They are controlled by code, encryption, and control of the electromagnetic spectrum. And in that invisible war, silence can be as significant as destruction.
Subscribe Info Beyond Borders now for more mind-blowing knowledge.